Okay, good afternoon all. Are you able to see the screen?
Yes, sir. Good afternoon.
Thank you. So today in this lecture, we will be discussing about operational amplifier in open loop. Okay, which means that you will not be giving any feedback from the output side to the inverting or non-inverting terminal. So open loop configurations, it means that there is no connection between the output and input terminals. So output signal will not be fed back in any form into the input side. That is what is meant by open loop. Okay, there won't be any feedback. So in open loop, the op-amp simply functions as a high gain amplifier. So the application of op-amp in open loop is very limited because it is just a high gain amplifier, very high gain amplifier. Now there are three open loop configurations. First one is the inverting amplifier. Yeah, in bracket I am writing open loop. And non-inverting amplifier, again open loop, and differential amplifier, open loop. So please note that there are three configuration of open loop op-amp. Now, first one we will discuss inverting amplifier in open loop. Okay, so please note that this is open loop configuration. Okay. So in inverting amplifier, only one input is applied. Okay, and the input is applied to the inverting input terminal of the op-amp. So as you know, there are two inputs to the op-amp. One is the inverting input terminal and the other is the non-inverting input terminal. Now in open loop inverting amplifier, the input will be applied to the inverting input terminal of the op-amp, and the non-inverting input terminal will be grounded. Okay, so this is the circuit diagram. Okay. You can see that the non-inverting input terminal, that is here, you can see it is grounded, and the inverting input terminal is connected to the voltage source. Okay. So let the open loop gain be A. Okay. So I have marked here, A. So A is the gain of the amplifier. So what will be the output? Can you tell me what is the output in terms of A and V in? So V in is the voltage coming at the inverting input terminal. Okay. And non-inverting input terminal is grounded. So what will be the output voltage? Can anyone tell? What is the output of an op-amp? It will be A into V. So VID is voltage at the non-inverting terminal minus voltage at the inverting terminal. What is the voltage at the non-inverting terminal here? What is this voltage? Voltage at the non-inverting terminal. How much is it? What is the voltage here? It is connected to ground. So what is the voltage?
0.
0. What is the voltage at the inverting terminal? It is connected to V in. So what is the differential input voltage? Voltage at the non-inverting terminal minus voltage at the inverting terminal. So 0 minus V in. Okay. So it will become minus A into V in. So I hope you guys remember output voltage is equal to A into VID. Correct. Where VID is the voltage at the non-inverting terminal minus voltage at the inverting terminal. Voltage at the non-inverting terminal is 0. Voltage at the inverting terminal is V in. So VID is 0 minus V in. That is minus V in. So V output will be equal to minus A into V in. Is it clear?
Yes, sir.
I have written here if you are getting confused. So differential voltage is voltage at the non-inverting terminal minus voltage at the inverting terminal. So it will become 0 minus V in, that is minus V in. So output voltage will be A into VID, that is A into minus V in. This output voltage is minus A into V in. Okay, so this is the inverting amplifier in open loop. Any doubt in this? Clear?
Yes, sir.
Okay. Now, negative sign indicates that the output voltage is out of phase with respect to the input voltage by 180 degree. Okay. So when the input is positive, output will be negative. That is what is meant by 180 degree phase shift. Okay, so in an inverting amplifier, the input signal is amplified by a gain of A and is inverted at the output. So if you are applying a positive input, output will be negative. If you are applying a negative input, output will be positive. Okay, so that is what is meant by inverted at the output. So now non-inverting amplifier. So tell me, how will the circuit be? Non-inverting terminal, what will happen? Where will you connect the input voltage? To which terminal will you connect the input voltage? In inverting amplifier, you connected it to the inverting terminal. So for non-inverting amplifier, where will you connect the voltage input?
Non-inverting terminal.
Non-inverting terminal. So in the open loop non-inverting amplifier, only one input is applied, and the input is applied to the non-inverting input terminal of the op-amp. And inverting terminal, what will you do? Inverting terminal, what will you do? In an inverting amplifier, what you connected? You connected voltage to the inverting terminal, and non-inverting terminal was grounded. Similarly, in non-inverting amplifier, voltage is connected to the non-inverting terminal, and inverting terminal will be what?
Terminal.
Where will you be connected to what? Inverting terminal will be grounded. Okay, please remember. So in a non-inverting amplifier, inverting terminal will be grounded. Whereas an inverting amplifier, input is connected to the inverting terminal and non-inverting terminal is grounded. In an inverting amplifier, in a non-inverting amplifier, input is connected to the non-inverting input terminal and the inverting terminal is grounded. So the circuit will be like this. You can see that non-inverting input terminal, I am applying the voltage, and inverting terminal is grounded. So tell me, what will be the output voltage? What will be the output voltage? What will be the output voltage? Okay, tell me, what is the voltage at the non-inverting terminal here? Just V in. What is the voltage at the inverting terminal?
0.
0. So what is the differential input voltage, VID?
0 minus V in.
Differential input voltage is voltage at the non-inverting terminal minus voltage at the inverting terminal. So what will it be?
V in minus 0.
So V in. So what will be the output voltage?
V in.
Only V in. A into V in, correct. I have written here. So please note here if you are not understood. Voltage at the inverting terminal is 0. So V minus I am writing. Okay. So V minus is 0. Now voltage at the non-inverting terminal is V in. So V plus is V in. Now differential voltage is what? V plus minus V minus. Voltage at the non-inverting terminal minus voltage at the inverting terminal. So it will become V in minus 0, which is V in. So output voltage is what? Output voltage is A into VID. Correct. VID is V in here. So A into V in. So output voltage is A into V in. Okay. So output voltage is in phase with input voltage in this case, because if the input is positive, output also will be positive. Okay. So please note that in a non-inverting amplifier, input signal is amplified by a gain of A, and the input and output voltages are in phase. Okay, next is differential amplifier. So can you tell me what will it be? To the non-inverting terminal as well as the inverting terminal, we will be connecting inputs. Correct. So two inputs will be there. One will be connected to the non-inverting input terminal and the other will be connected to the inverting input terminal of the op-amp. So it is like this. So can you tell me what will be the output voltage? What will be the output voltage?
A into V.
A into?
V1 minus V2.
Correct. A into V in 1 minus V in 2. Correct. Okay. So explanation I have given here. Voltage at the inverting terminal is V in 2, which means V minus is V in 2. Correct. Then voltage at the non-inverting terminal is V in 1. So V plus is V in 1. Correct. Voltage at the non-inverting terminal is V in 1 and voltage at the inverting terminal is V in 2. So differential voltage is V plus minus V minus. So it is V in minus V2. Output voltage is what? A into VID. So A into V in 1 minus V in 2. Okay. So output voltage is equal to the voltage gain A times the difference between input voltages. Is it clear?
Yes, sir.
Okay. We'll do a small problem. Okay. Determine the output voltage for the open loop inverting amplifier if V in is equal to 20 microvolt DC. Second case, V in is equal to 2 millivolt DC. Third case, V in equal to 20 microvolt peak sine wave. V in is equal to 2 millivolt peak sine wave. Okay. Assume that the op amp is 741 and VCC is 15 volt and VE is minus 15 volt. Okay. So let us do. So first thing is, this is the figure. Correct. So you have input. Inverting amplifier means, inverting open loop amplifier means input will be connected to the inverting input terminal. Is it clear? Yes or no?
Yes, sir.
Yes, sir.
Okay. So now output voltage, the open loop gain of an 741 op amp is 2 into 10 power 5. Okay. So please remember this. Open loop gain of a 741 operational amplifier is 2 into 10 power 5. So output voltage of the open loop amplifier, what is it? Minus A into V in, correct. V output is minus A into V in. So first is minus A, so V output will be equal to what? 20 minus 2 into 10 power 5 into 20 into 10 power minus 6. How much is that?
Minus 0.4.
Minus 0. Minus 4 only, right?
Yes, sir.
20 minus 40 into 10 power minus 1, that is minus 4 volt. So minus 4 volt you will get as the output voltage in the case 1. Now in case 2, can you quickly calculate how much will it be? Case 2 means input voltage is 20 millivolt. 20 millivolt means what? 20 into 10 power
Minus 3.
minus 3. So can you quickly calculate and tell me? How much will it be?
Minus 14 to 10 power 2.
So but okay, that is correct. So you will be getting like this. I'm doing here. So as you told, minus 400 volt you will get. Okay. So correct only, right?
Yes, sir.
Okay. So minus 400 volt. But our input volt, our bias supply is only 15 volt and minus 15 volt. So what has to be done? It means that if the output voltage is less than VEE or more than VCC, it will go to saturation. Op amp will go to saturation. So please note here, I have written here, since this voltage is higher than the saturation voltage, the open op amp will go to negative saturation. Why? Negative because output is negative. Understood? Negative because output is minus 400. Minus 400 means it is going to negative saturation. So output will be equal to my negative saturation. So negative saturation voltage we have already told it is 94 percentage of VCC. So 94 percentage of 15, which is 14.1. So output will be minus 14.1 volt. Is it clear?
Yes, sir.
Okay. So that is what I had shown last time. I will show you again. Those who did not. Okay. So here I will show you this. Okay. I will open the same thing. So we'll do that both the cases and see. Okay. So first was 200 microvolt DC. So 20 microvolt DC. Let me close this. 20 microvolt DC. So let us give this 20 microvolt. Okay. So now it is 20 microvolt. Okay. And supply voltage is given as 15 and minus 15. So I will change here. Okay. This is 12 now. I will change it to 15 positive voltage swing and negative voltage swing minus 15. We'll run this and you can see that it is, oh sorry, it is connected to inverting. So it has to be connected to the inverting terminal, correct? So this is connected here. Okay, to the inverting terminal, we are connecting the input voltage, and this is okay. So now I'll run. You can see that it will be minus 4 volts, which is same as we got here. First case, minus 4 volts. Now let us see when I am giving 2 millivolt, what will happen. Okay, so I'll stop this. I'll change it to 2 milli. Okay, I'll run. You can see that it will be minus 15. Is it clear? You will not get, what is that, minus 400 volt, because op amp is going to negative saturation. Is it clear?
Yes, sir.
Okay, we'll continue with the problems. So in practical op amp, you will be getting minus 14.1 as the output. Okay, but since it is simulation, it is showing minus 15 itself. So next is C, that is 20 microvolt peak to peak sine wave. Okay, so 20 microvolt peak sine wave means you can write like this: 20 into 10 power minus 6 sine omega t. Okay, peak value means maximum value. So maximum general format of a sine wave is what? Vm sine omega t, where Vm is the maximum or peak value. So here it is told 20 microvolt peak sine wave. So Vin can be written as 20 into 10 power minus 6 sine omega t. We don't know the frequency, some frequency. Is it clear? Is this part clear?
Yes, sir.
Okay.
Yes, sir.
So again, output is what? Minus A into V in. So minus A. A is 2 into 10 power 5 into V in. That is 20 into 10 power minus 6 sine omega. So this will become what? Minus 4 sine omega t. Is that correct? Understood?
Yes, sir.
Okay. So it will be like this. So you have a 20 microvolt peak sine wave. So sine wave is like this, correct? So when the input is positive, output will be negative. That is why this negative sign. Is it clear? Yes or no?
Yes, sir.
Okay.
Yes, sir.
And peak of the sine wave is 4. That is why 4 and minus 4. Okay. So this is what is called 180-degree phase shift. Okay. When the input is positive, output is negative. When the input is negative, output is positive. That means 180-degree phase shift is there. Okay. Actually, for a sine wave, this is 0 degree, this is 90 degree, this is 180 degree. Correct. I hope you know that. This is sine 0, 0. This is sine 90, maximum 1. Then this is sine 180, that is 0. Okay. So, okay, 180, and this is 270. This is 360, one full revolution. Okay. So you can see that if you shift this signal 180-degree, you will get this. Correct. Shape will be like this. That is why it is told 180-degree phase shift. So whatever value is here, it has come here. I mean, the shift phase, whatever was here, it has come here. Whatever was here has come here. Okay. So 180-degree, it has moved. That is why it is called 180-degree phase shift. Okay. So when I am applying a 20 microvolt peak sine wave, I am getting a sine wave itself. Okay. So I'll just quickly show you that. So instead of this, now I will give a sine wave. Okay. So here in sources, there are sine waves, that is AC voltage. I'll give it here. 1 kilohertz itself I'll give. Okay. And input voltage peak value is 20 micro. So this is our input now. So let us go and see what is happening to the graph. Okay, this is the output. Okay. If you want to see the input also, you can see. I'll take one more voltage probe and connect it here so that you can see the input also. But together to see will be difficult because one is very small voltage and one is high voltage. Anyway, we will give like this. So this is V in. Now if I simulate both, okay, you will be able to. Okay, so input is here, but we cannot see the sign because it is a very small voltage. Okay. Maybe I will just, if I don't show the output and then click on voltage, you can see. It is very difficult to see because of the slow voltage. Okay, low voltage. Maybe I will remove this. Then maybe you will be able to. Let us see. Ah, see here, this is the input voltage, 20 microvolt, a very small voltage. Okay, and the output is very high voltage. Okay, you can see this is the 20 volt. Okay, but when I you will not be able to see that because it is a very small voltage. Okay, so that is what is happening. Okay, now we'll continue with the fourth one. The fourth case, we are giving 2 millivolt peak to peak sine wave. So 2 millivolt peak sine wave means how will you write it in sine wave form? Can you tell me how will you write it? Sine wave, how will you write? V in equal to, how will you write? Anybody? How will you write? Please tell me.
Yes, sir.
How will you write? Right, sine omega t. So it will be 2 into 10 power minus 3 sine omega t, correct? Peak value is 2 into 10 power minus 3, that is 2 millivolt. So V in can be written as 2 into 10 power minus 3 sine omega t. So what will be the output voltage? Minus 2 into 10 power 5 into 2 into 10 power minus 3 sine omega t. So what will happen? It will become minus 400 sine omega t. But will you get minus 400 voltage? 400 voltage will you get? Yes or no? My God, you guys are not at all paying attention. Okay, I don't know how you guys will pass this particular course. How many times I told? Will you get minus 400 volt as the output voltage? The maximum negative voltage it can go is minus 15. Okay, so here it is showing that it's going to minus 400, which cannot happen, which means that the op amp will go to negative saturation. Okay, so it will be like this. It will reach minus 14.1 and it will be a straight line like this, because above 14.1 it cannot go, below minus 14.1 it cannot go. So you will be getting a waveform like this. Please take the course seriously. I don't know what you guys are thinking. Okay, so here 2 millivolt I am giving, you can see the waveform. Yeah, see, it is going up to 15 only, then straight, which means it has gone to saturation. Again, it is coming here, it is going to saturation, going to saturation. So it will be between positive saturation and negative saturation like this. Is it clear? Any doubt in this? Please reply.
Yes, sir.
Okay. Okay, one more problem we will do and wind up. Okay, question is, in the differential amplifier shown below, find the output voltage if V in 1 is 4.1 microvolt DC and V in 2 is 4 microvolt DC. Okay, first case. So tell me, what is the formula for output voltage of a differential amplifier in open loop? What is the voltage connected to non-inverting terminal? What is the voltage connected to non-inverting terminal?
V1.
V in 1. What is the voltage connected to inverting terminal?
V in 2.
So what is the differential input voltage? Differential input voltage means voltage
V1
at the
minus V2.
V in 1 minus V in 2. So what will be the output voltage? Expression for output voltage.
A into difference between the voltage.
So A into V in 1 minus V in 2. Correct. So output voltage will be A I told it is 2 into 10 power 5. Output voltage will be A into V in 1 minus V in 2. So 2 into 10 power, first case if you write, V in 1 is 4.1 microvolt, that is 4.1 into 10 power minus 6 volt. V in 2 is 4 microvolt, that is 4 into 10 power minus 6 volts. So output voltage will be 2 into 10 power 5 into 4.1 into 10 power minus 6 minus 4 into 10 power minus 6. So can you tell me how much will you get as the output voltage? How much will it be? 4.1 minus 4, that is 0.1 into 10 power minus 6 into 2 into 10 power 5. How much is that? I don't know. Okay. V output will be 0.02 volts. So if I connect here, you will be able to see. So two voltage sources I will be connecting. And the non-inverting terminal, I will be connecting one 4.1 microvolts. Okay. And that inverting input terminal, I am connecting 4 microvolts. Okay, so you can see 20 millivolt. 20 millivolt means 0.02 volt. That is what we have got here. Okay. So second case, can you try? Second case is V in 1 is 5.6 into 10 power minus 3 and V in 2 is 5 into 10 power minus 3. So what will be the output voltage? Can you calculate and tell? How much? A is 2 into 10
12.
power. How much?
12.
12. No, right? A is 2 into 10 power 5, correct? So A 2 into 10 power 5 into 5.6 into 10 power minus 3 minus 5 into 10 power minus 3. So how much is that? 0.6 into 10 power minus 3 into 10 power 5 into 2. How much is that? It will be like this. So how much is this? How much will this be?
120.
120s. But will you get 120?
No, sir.
So how much? What will happen? Op-amp will go to positive saturation or negative saturation?
Positive.
Positive. So what will be the output? Positive saturation means how much voltage? If 15 is the supply voltage given, what will be the output? 14.1. Is
1.
it clear? So output will be, in simulation you can see that it will be 15. Actually it will be 14.1 volts. So that also I'll show you. So 5.6 and 5. Okay, so this is 5.6 millivolt and this is 5 millivolt. We can see output is 15 volt, which means that the op-amp is in positive saturation. Now suppose I am giving here 5 millivolt and here 5.6 millivolt. What will happen?
Negative saturation.
Negative saturation, and output will be how much?
Minus 14.
Minus 50. So minus 14.1, or here it will be minus 15. Clear? So it will be like that. Is it clear?
Yes, sir.
Okay. So if you have any doubts, you can ask. 6 minutes is the. Okay, please go through it. Now next class onwards, it is very, you have to be very attentive. Okay, we will be starting the actual analysis from the next class onwards. That is tomorrow. So I'll upload the slide today itself. Please go through it. If you have any doubts, please ask. Okay, study that day itself. Otherwise, it will be very difficult. Particularly, it is a new subject for you. So please. And only 1 or 2 students are interacting. I don't know what others are doing.